Welcome to our video tutorials to get started with controllers from STW. In this video, we would like to show you how to detect and fix problems with CAN communication between a PC with OpenSide and a controller from STW. On a CAN bus, the individual devices, so-called nodes, are connected one after the other. Star-shaped architectures are also possible in principle, but are subject to certain restrictions. In our simple test setup, only the OpenSide client PC and the controller are connected to the CAN bus via the breakout board. The cable lengths have an influence on the maximum possible bit rate on the bus, to which all connected devices must be set to the same value. In our case of a test setup in the lab, e.g., with the starter kit of the ESX3CS, the line lengths are of course far below the critical values. The CAN cable should be twisted and, in the best case, shielded to minimize interference. This is the case with the cables from the starter kit. The beginning and the end of the bus must each be terminated with a 120 ohm resistor between the CAN high and CAN low lines. Such terminating resistors are available, for example, in adapters for the D-sub connector. But we use accessories from the starter kit, namely the CAN connection cable with the switchable resistor and the resistor switchable with dip switches on the breakout board. This allows us to properly terminate the bus in our experimental setup as close as possible to the beginning and end. If the communication between the PC and a controller from STW via the CAN interface does not work, this can have various causes in the software installed on the PC. The driver software for the PEEK CAN USB interface in connection with STW applications has 3 levels. 1 driver from PEEK, 2 drivers from STW. If the driver from the PEEK company is properly installed, we need to find it in the Windows control panel. We select PEEK hardware here, and we can see which hardware was installed with which driver. A simple test of PEEK's hardware is possible through the LED on the interface. We plug the interface into a free USB port of the PC without any further connection to a CAN bus. The LED must then light up constantly red. If this is not the case, we uninstall any existing installations of PEEK. Then we obtain the latest driver software from PEEK's homepage and reinstall this software, requiring administrator rights on the PC for the installation. We have shown this in detail in the video, getting started with CAN communication between PC and controller. The drivers of STW are delivered together with OpenSide. In the installation directory, we find the subdirectory CAN driver installation PEEK, and there the installation routine pcan dev redist. We start this routine and follow the instructions on the screen. We have also shown this in detail in the video, getting started with CAN communication between PC and controller. For CAN communication, a CAN network must still be set up in the software. We at STW have always used the name testnet for this. You can set up this network either via the program pcan-nets configuration or via OpenSide. In both cases, the USB interface must be plugged into the PC and ready for operation. We first look at the possibility via OpenSide, and for this we start a project that we already know from the video, getting started with application programming. In system commissioning, in the setup for the view, we double-click the PC icon and get in the following dialog the possibility to configure the peak interface. The empty field in the group network already indicates that there is no CAN network yet. We click Create and assign testnet as name. We leave the other parameters as they are and confirm with OK. We can now test the created network and should receive a positive response, as shown here. Alternatively, we could have used the program peek-and-nets configuration for setting up the network. We got it by installing the driver and started from the Windows menu. Here we see the network testnet just set up with OpenSide. We could also have set it up here with the button New Net. We can monitor our CAN network with two tools. One is the program Peek-and Status Display from the company Peek, which we got by installing the driver. We start the tool from the Windows menu. Another tool is the OpenSide CAN Monitor, which we can start from the system commissioning in a new window. With the CAN monitor, we can record all CAN messages. So we'll start the recording. If we now start the device configuration in OpenSide, as an example, we see on the one hand in the program, P can status display the applications involved in the communication, the CAN network testnet, the used bitrate, and via the status indicator OK that the bus is running properly. In the CAN monitor, we see in detail which messages are exchanged. If you are not sure which bitrate the CAN bus of a controller is set to, for example, because the controller has not been delivered fresh from STW but perhaps comes from a test setup whose configuration you do not know, you have to try the bitrates one after the other. In parallel, you can use the tools of OpenSide and Peek and observe the CAN bus. In our test setup, we have now included a controller with an unknown bitrate. In our OpenSide project, the CAN bus is configured to 125 kilobits per second. Therefore, we try the device configuration with 125 kilobits per second. OpenSide shows that the controller is not found. At the same time, we see in the PCAN status display the used bitrate and the status bus heavy. We try the next bitrate. We see the changed bitrate in the PCAN status display, but still the status bus heavy. We try the next bitrate. Now it works, and also the bus status is OK again. So the controller was set to 500 kilobits per second. We can now reconfigure the controller to 125 kilobits per second according to the settings of our project. With a further device configuration, we must pay attention, of course, to use from now on this just set bitrate again. Another possible source of error for non-functioning communication between PC and controller can also be in the application. This actually has nothing to do with the CAN interface, but can ultimately only be resolved via the CAN interface. If the controller is to be flashed with OpenSide, it must be set to flash loader mode. Therefore, the OpenSide server must be running in the application, which puts the controller into flash loader mode at the right time, allows access for flashing, and resets the controller after flashing. For demonstration purposes, we have now replaced the controller's application with an application without an OpenSide server. However, to be able to exclude all other errors, we must install an empty template application. We can select this from the TSP of the controller instead of the application of our currently used project. So, we'll change the hex file in the update package. If we now try to enter the update mode, OpenSide reports the failure of this process because without the OpenSide server, the controller cannot be set to the update mode. We also observe on the LEDs on the controller that the update mode is not reached and the application continues to run normally. By switching off and on at the right time, we can still force the update mode. Only at the CAN interface, the controller waits for a few milliseconds after each switch on for the command to switch to the flash loader mode, i.e. the update mode. If it does not receive the command from OpenSide, the controller starts the application. So we click on Enter Update Mode in OpenSide again and observe the progress log window. If the message Entering Update Mode appears, we switch off the controller and immediately switch it on again. Since OpenSide sends for some seconds constantly the command to switch on the update mode, this is reached now. We recognize it by the blink code of the LEDs and in OpenSide. We can now flash the controller with the template application. From now on, the OpenSide server is in operation again, and if we switch to the update mode once more, this also works without switching the controller off and on. I hope the tips on how to fix possible problems with the CAN interface will help you. I wish you every success in using the CAN interfaces of STW controllers.